Hi, everyone, and welcome to another Sunday Talk within the Nine-Sided Circle. I'm one of your hosts, Noor Kyle, along with...
the other one of your hosts, Mushtaq Ali.
Yep. And someone new is joining us. There we go.
Got it.
But here we are. We have a very special talk tonight because this one is going to be rather on the instructive side. We're going to be learning about the Pythagorean Enneagram. And before we get to that, we got to do our usual spiel. And thank you all for joining us either live or on the playback on YouTube. Thanks for being here. It means a lot to us. And if you enjoy our work, you can give us a thumbs up. You can leave us a comment. You can join us on Facebook and on Instagram. You can join our mailing list to stay updated on the things that we're doing. And we do send out updates probably once a week just to let you guys know what we're going to be doing for our Sunday talk and to send out the link to join in. And you can also leave us comments, of course. We try to respond to every single one. And if you don't like our stuff, you can always give us a thumbs down, and we love that too. Press. All press is good press, right? So that's what I got. Do you want to add anything, Mushtaq?
No, I think you covered it all.
There you go. So, Mushtaq.
Yes.
Yeah. Do you want to say anything in introduction, or should I? Well, okay.
Things are about to get weird, folks.
Yes. So, Mushtaq.
Yes.
We are talking about the Pythagorean Enneagram tonight. What is an Enneagram?
Enneagram is a Greek word that means nine-sided figure or diagram. Ennea means nine. Gram means a figure. And in this particular case, we know this word from the writings of the people around G.I. Gurdjieff. He introduced it to the Western world at the turn of the 20th century in Moscow and St. Petersburg in Russia, where he arrived from the East with a bunch of his students, kind of out of the blue, picked up some more students, and then split from there when the Russians decided to have a revolution.
So who is Gurdjieff exactly?
Okay, Gurdjieff was this quasi-mysterious figure. He was of Georgian, maybe Turkish descent. He grew up in a town called Tashkent, which is in is that in Uzbekistan? East of Turkey. But it was a Russian holding at the time. And he brought what he called a new teaching. And it was unique for the time. Back when he showed up, what you had was Madame Blavatsky's stuff, her theosophy, which was all about the ascended masters telling her stuff that then she dispersed to her students. And you had things like the Golden Dawn, which was all ceremonial magic. That's Aleister Crowley and the poet Yeats and various peoples like that. And that was all, thinking that you could get someplace by doing ceremonies and dressing funny.
Yes, which is not necessarily a philosophy we endorse, or...
I don't know, I dress pretty funny.
Yeah,
well, I'm picking on them a little bit because there was more to them than that, but
right.
It wasn't what, as those of us who are fond of him call him Mr. G, brought to the world. He brought something totally different. And it involved a lot of very cool stuff. And it involved the first guy really to say, hey, you need to be embodied.
Yeah.
Yeah, he referred to himself as a dance teacher, and he taught sacred dance. The only other person doing that sort of thing around the same time was Rudolf Steiner with his Eurythmics. or eurythmy. Eurythmics was the group, but eurythmy. And so one of the things that he brought was the Enneagram, and he described the Enneagram in a couple of ways. And I just happen to have the quotes right here in front of me. He said, he called the Enneagram the fundamental hieroglyphic of a universal language, which has many different meanings as there are levels of people. The Enneagram is a kind of Rosetta Stone for mapping and relating different systems of knowledge. By the way, hieroglyph, for those of you who don't know it, people think hieroglyph and they think Egypt, which they should, but it means a sacred carving. And it's a Greek translation of the Egyptian phrase, the gods' words. And pop quiz, what are the gods' words? Yes, Chris, you know the answer to this.
Logos.
Yes. Even more fundamentally than that, and we'll get to logos in a second, but numbers. Certain mystical brotherhoods were pretty convinced that God thought in math.
So one thing about the Enneagram you'll notice is that at least in the form we know it today, we incorporate that into our logo, in a lot of the work that we do. So if you've never seen this symbol before, you can see it in our content. Pretty much every video we do, it's sitting in the corner. So yeah, take a look at that if you're not familiar. And what we're going to be talking tonight about is kind of the precursor to that. So Mushtaq, quickly, how did you come to study the Enneagram in general and the Pythagorean Enneagram in particular?
Well, many, many years ago, around 1967, I was running around in Haight-Ashbury. And there was a free bookstore there. And I got a bunch of very cool free books out of it over the period of the 4 months I was there, and 4 or 5 months. Seemed like forever at the time, but that might have had to do with what I was eating or maybe smoking, who knows. But one of them was a book called In Search of the Miraculous. And that was written by Pyotr Ouspensky, the Russian mathematician. And he had run into Gurdjieff in Moscow, I believe it was. Moscow or St. Petersburg, one of the two. And this was an account of his going to the meetings with Mr. Gurdjieff and all the stuff he talked about. And one of the things that Ouspensky talked about was the Enneagram. Now, this is way before Oscar Ichazo ever did his Enneagram stuff. And it was a completely different teaching that dovetails a little bit with what Ichazo did, but that's for a different meeting. But this is the original Enneagram. And, you know, I read the things about how two dervishes would meet, and if they were of the group that understood this stuff, they could draw an Enneagram on the ground, and through a series of questions and answers of each other, determine which one knew the most and would become the teacher for that moment. This turns out to be absolutely true, strangely enough. And we use this even to this day. And it's very amusing because there are now a lot of people who pretend to be experts in the Enneagram, but they can't even answer the beginning questions on this. So we will touch on that later too.
So how about the Pythagorean Enneagram?
So the Pythagorean Enneagram I ran into after I went to Iran. Is Zainab here? Are you here, Zainab? There you are.
Zainab is here. She's waving.
So, the first time I ran into the Pythagorean Enneagram was in Iran, in a Sufi house, in a khanagah, where we were talking about sacred mathematics and alchemy. and astronomy and astrology. And this came up. And we talked about the great mathematician Omar Khayyam. Did you know? You know that Omar was a poet, right? But he was a mathematician way before he was a poet, and he was a an astronomer, and he was one of the people who rewrote the Iranian calendar for the Shah of the time. And to this day, some of his math it's very important things in math in Iran, at least, are named after him. One of the things we're going to talk about is Omar Khayyam's triangle. So what is the Pythagorean Enneagram? This is something, you all know who Pythagoras was. Let me refresh your minds. So Pythagoras was a 6th century BC mathematician, philosopher, and mystic. I'm going to go over this very briefly. We can talk about it in depth at other times. I will have to tell you that in putting together my presentation for this week, this is actually probably a 12-hour course minimum, and I'm going to squeeze as much of it I can into probably a little bit more than an hour. But Pythagoras was this Greek dude, and he's most famous for, y'all know the Pythagorean Theorem. The square of the hypotenuse of a right triangle is equal to the squares of the sums of the two other sides. He didn't invent that. That was known 1,000 years before him, but he got named for it. And there's a reason that he got named for it, because he was the guy who brought it back to Greece. So Pythagoras was the son of a Phoenician merchant and a Ionian Greek woman. We don't know too much about his family. There are some rumors that his father might have also been a gem carver, but we do know that he was a merchant, and that Pythagoras traveled with him as a young man. We know that Pythagoras studied with two famous Greek mathematicians, Thales and Anaximander, who both studied in Egypt, and who urged Pythagoras to go to Egypt to complete his studies. So young Pythagoras packed up his duds and moved to, I think it was, where did he move to? I don't remember. He moved to Egypt, and he studied math there. And this is important because Egyptian math affected Greek math to a very great extent. I would say that the Greeks got 80% of their math from Egypt. Now, the important thing was that this was the time when Cyrus the Great was expanding the Persian Empire. And he was putting a lot of pressure on Egypt. He wanted the territories of Egypt really bad. And his son, Cambyses, went and conquered Egypt. And in the process of doing this, his troops captured Pythagoras. And they took him back to Babylon. And he spent 5 years there as the guest of the king. And this is where it's important to realize that having a Phoenician father was really important, because the Phoenicians were very, very important allies of the Persians. They kind of made sure that the supply lines across the oceans stayed open. And so you would not want to alienate a big Persian merchant by maybe killing his son. So Pythagoras was treated very, very well, and he was introduced to the teachings of the Magi, where one of his biographers says he learned a very mystical worship of the gods from them. And he also perfected his arts in music, mathematics, arithmetic, astronomy, and all of the other sciences. And then after 5 years, he was allowed to go home. Now, why is this important? Any ideas?
Yeah, feel free to chime in either via voice or via chat.
You know, the Chaldean oracles are held in high esteem by a lot of Neoplatonics and other folks. And so that's just one example of the kind of wisdom that was there that Pythagoras became privy to.
Yep.
Thanks, Chris.
You know what the most interesting thing Pythagoras learned about in his stay in Persia? The thing that he never wanted to talk about. He learned about two things there.
Travis offers the Enneagram.
Well, yes, there was that. But in general, he learned about the zero and irrational numbers, both of which he didn't like. This was like one of the big secrets of the Pythagorean Brotherhood. The Greeks hated the concept of zero. They didn't use it in their numbers. As a matter of fact, when they did astronomy, they would use the Babylonian mathematical system, which is a base 60 system with zeros. The zeros were just placeholder zeros. They weren't the true zero yet, but they were nevertheless a void. And then once they worked out the astronomy that they wanted to work out, they would translate it into Greek numbers, which are like Roman numbers, but with Greek letters instead of Roman letters. That's how much they hated the concept of zero. They never wanted to show it. And
Quirks. They got quirks.
Yeah. Irrational number literally means a number without a ratio. Pythagoras, his idea of how the universe was constructed was in pure ratios. When you look at the Pythagorean scale, it's based on pure ratio. Specifically the 3-2 ratio, the perfect fifth. And he discovered that by stopping a monochord and then discovering that he could pluck either side of the monochord and get these two perfectly in tune notes that felt really good just to listen to them. And he used the octave, the fourth, and the fifth to base his scale around. Now, we are getting to the Enneagram. When he came back and he moved to the ball of the foot of Italy, to a little town there, and he formed his school. Sorry about that, folks. It's somebody who actually can get through my my muted phone, but I don't have to worry about it for the moment. But he formed a school called the Semicircle. And the semicircle had 2 layers of students. It had one layer that were the outer school, and those people lived in town, and they would come during the day, and Pythagoras's inner students would teach them. Pythagoras wouldn't teach them directly. Acousomatics, they called them. And then there was the inner school called the Mathematikoi. The Mathematikoi they lived in the school. They gave up all worldly connection, basically. And they had 5 vows that they took, which were, these were 5 axioms. The first is that at its deepest level, reality is mathematical in nature. The second was that philosophy can be used for spiritual purification. The third is that the soul can rise to union with the divine. The fourth, and here's where it gets important, that certain symbols have a mystical significance. And last but not least, and the thing that is really sucky, is that all members of the order should observe strict loyalty and secrecy. And this is a problem because they were really good at this. So we have no direct writings of Pythagoras. We don't know what he said. We only know what his students or the students of his students said that he said. But we have still been able to piece together a fair bit of his teachings from those accounts. And as to symbols, there were two that were really important to him. The first was the pentagram. And the reason the pentagram was important is, one, it's fractal, because you draw a pentagram and then in the pentagon in the center of the pentagram, you can draw another pentagram and then it just keeps going down. And secondly, because the lines of the pentagram all follow the golden ratio. So, and ratio was everything to Pythagoras. Y'all know what a ratio is, right?
Do you want to define it real quick?
Okay, a ratio is a relationship between two whole numbers, basically, or two numbers that are have a decimal, but the decimal is either like 2.5. You can have 2.5 and 9.5, 2.5 over 9.5. Think of fractions. Fractions are ratios. As long as they either are recurring decimals or the decimal stops, you're good. So like the 3-2 ratio that forms the perfect fifth in the musical scale is a ratio that was really important. And Pythagoras said everything in the universe is ratio. But secretly, he knew that there were these irrational numbers and that not everything fit into ratios. But this was one of the things that you were not allowed to talk about in the school. The one time that one guy talked about it, Pythagoras ordered his death. He was rowed out to sea and thrown off a boat and drowned because he talked about one of the most obvious of the irrational numbers, which is the square root of 2. Now, if you draw a square, right, you have 4 equal lines. If you draw a diagonal across that square, you will try and get a ratio. And you would get the ratio by taking some unit of measurement, and like, say, the lines are 12 inches. So you would take a 1-inch measurer and you would measure to see how many inches were there, or a 1/2 inch. So you get 24 if you're using a 1/2 inch, 24 units. But if you go to that diagonal and start measuring it, you will not get a whole number. It will be slightly over or slightly under, and it will always be that no matter how you try and measure it. And this is not something that Pythagoras wanted to admit to. And there are all sorts of irrationals. The square root of 2 is just one of the early ones. You have the most well-known of the irrational numbers is pi, right? We use that to figure out the area of a circle. And then there's e, which is pretty weird, phi, which gives us interesting progressions of numbers. There's lots of them. And Pythagoras probably knew a good number of them, and you were not allowed to talk about them outside of his school. And if you did, it was on pain of death.
So why is that though? Why the drama? What's that about?
Because it went against the stated philosophy that the universe is rational, in that everything follows these ratios. All perfection is found in ratio, but the universe is more chaotic than that. And he knew it, but he didn't want to say it out loud. Of course, this allowed him to do things mathematically that other people couldn't do. Now, let me tell you about this. What is the first plane? If I were to do a figure that was a geometric plane, what would be the first plane that I could do?
Triangle.
Exactly, the triangle. So I'm going to pull up an image for you here. No, not this image. Let's try this again. Where are we? There. All right, here is an equilateral triangle. Now, Pythagoras would look at this and say, perfect ratios, very cool, all of this. And so he would unfold this triangle. And the way he would do that is first he would unfold it into two more triangles. So he takes this one and folds it here. And then he takes this one and unfolds it here. And then he would unfold it into three. Now here we have three triangles. This contains most of the secrets of the Pythagorean universe, but he doesn't want you to know that. So instead of showing the triangles, he puts these 10 dots at the points where the triangles meet. And then he makes the triangles go away, and you have the tetrachus. This is the source of Pythagorean knowledge. You have 1 point, which is no dimensions. 2 points, which is 1 dimension, a line. 3 points, which gives you 2 dimensions. So you can do anything in 2 dimensions using 3 points. And then 4 points, which gives you 3 dimensions. Now, this, up until the beginning of the 20th century, in most of the Sufi world, was the Enneagram. Can you see the Enneagram in this? Anybody?
I know I struggle with that.
Yeah. Well, I may have to go back to this. So you have 10 dots. How do you get an Enneagram from that? First of all, I want you to notice that there is a perfect hexagon here. You see that? You see the hexagon? Yes, no, maybe? I can't see your faces while I have this up, so.
Oh, okay.
Yeah.
Yeah. Totally. It looks beautiful.
Okay. And I can see your thumbs up even if you guys don't chime in. I'm looking
Yeah.
at the videos right now. So.
Okay, this is important because there was one pretender to the head of Sufism who said the Enneagram is hidden in the octagon. And this is not true. It's hidden in the hexagram. And this is why, at least in our particular tariqah, the symbol of the bee is so important. So let me show you what happens next. I just spread out the hexagon, just took the points and moved them out a little bit more. And then I'm going to draw lines between them. And then it looks like this. I can draw this triangle, but it doesn't connect to the hexagon. And I can draw these lines in the hexagon. And that gives us all of the lines of the Enneagram. If I start here, 1, 4, 2, 8, 5, 7, 1. Here's the outward circle going around, touching all of the points. And then there's these 2 lines that we never talk about, except that I'm probably going to talk about them at some point. And in the center, this 10th dot represents the equator. The equator is when you are walking through the process of the Enneagram and you move from 4 to 5, you make unrecoverable changes. You can't go back after that point. You cannot recover what you were before. If you go back and look at the video that I did on the Enneagram of the kitchen, and I'll put a link to it somewhere up here, probably right there. A little thing will pop out and go, Enneagram, go watch this video. It'll tell you all about that. And this was how you understood the Enneagram. If I go back, now that I know that those lines are there, I can visualize that on this. And that's how it used to be done.
Stealthy.
Very stealthy. It's a hidden teaching. And it's interesting that when Mr. Gurdjieff gave the new Enneagram symbol, he used these patterns, but he left out these two lines here.
So those are connecting which dots for those who are listening rather than watching?
This is 5 to 7,
Mhm.
or 4 to 7,
4
and
to 7.
5 to 2.
Right. Yep.
And those are very important for understanding the crossing of the horizon if you are the teacher. If you are the B in the center of the Enneagram, and the person that you're working with gets to point 4, and you know that they have to get across the equator to 5, you look from 4 to 7 to see what they need. And when they get to 5, you know that they're going to have to get through this shock, and you look from 5 back to 2 to find out what they're going to need to get through the shock. We'll go into this later, probably in the long course that we do. And when I do that, we're going to talk about these two lines extensively because they are not understood by anybody that I know who is writing Enneagram stuff in the world today. Gurdjieff never talked about them, at least not publicly to anybody. And so we're kind of stuck with not having that. Now, what did Pythagoras do with this? He would put these numbers on there. As far as we know, we don't know that he did this. The stories handed down say that he did this. We know that this pattern goes back, we can historically date it to the 3rd century BC in India. The first person to write about it, whose writings have been at least somewhat preserved, though fragmentarily, is Arkhi Pingala. And what do you notice about this when I lay this out in this way? What relationships can you see?
First thing that I'm drawn to is the 2 there in the center of the hexagon.
How did that 2 manage to get there?
Right.
Yeah, there are secret zeros in this, by the way. If you were to really write the thing out, there would be zeros going down this side and zeros going down this side in front of and behind these numbers. But since Pythagoras didn't use the 0, he left them off, and you can still do this sequence without them if you know that they're there. How about the 3s? How did these numbers get arranged like this?
1 plus 1, 1 plus 2.
Yes. So 1 plus 2, 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 1 equals 3. This is a sequence that can be mapped out infinitely. Today in the world, in the West, it's known as Pascal's triangle, from Blaise Pascal, the 16th century French mathematician, 17th century French mathematician. And he did some wonderful work on it, but he was a Johnny-come-lately. Pascal got to name it in the West, but
yeah, this goes way back, doesn't
yeah,
it?
this goes way, way back. So we know about it from as early as the 3rd century. In India, this was called Meru Pastara, which means the staircase of Mount Meru. And if you know Mount Meru in Hindu mythology, it's the mountain at the center of the world. Somewhere in the late 900s, early 1000s, a Persian mathematician by the name of Al-Kharajhi wrote about it in a book that no longer exists, unfortunately. We only have references to the book. But somewhere around 1060, 1070, Omar Khayyam wrote extensively about this. And in Iran, to this day, this is known as Khayyam's triangle. Now, to bring this back to Pythagoras, let me read to you the Pythagorean Prayer. Bless us, divine number, thou who generated gods and men. O holy, holy Tetrachus, thou who containest the root and source of the eternally flowing creation. For the divine number begins with the profound pure unity until it comes to the holy four, and then it begats the mother of all, the all compromising, all bounding, the firstborn, the never swerving, the never tiring holy 10, the key holder of all. So, to see how this goes together for everybody, I found this little thing here. You can see how the additions go. And this is just a simple combination.
Yep. So this is exactly like Mr. Keen was saying.
Yeah,
1
exactly.
plus 1 goes to 2. 1 to 2 goes to 3. And then we add on 1 plus 3 equals 4. So that's an extension of the Pythagorean Enneagram as we're looking at it today.
Yep. So let me go back here. And so we have, what could you use this for? Any thoughts?
Yeah, what do you guys think? Chris, I saw you unmute yourself. I'm sure you have thoughts.
Yeah, I think in one sense it allows me to start to image how unfoldment happens, and then there's just other things that, like, there's a double and a tripling pattern within this too. You know,
Oh,
there's
yeah.
like, so there's so this this is fantastic, and behind it is like so many ways in which this pattern is used for all kinds of things. And so as a meta map, phenomenal.
Mm-hmm. So let's look at some things that we can see. One of the things that we can see is that if you go along the lines this way, you can use this to discover the powers of 11, which is kind of weird. And you can do that with all of the numbers, even usually you can just add these up and you get the power of 11 for this row. And you number these rows actually from 0 to 3. And so the third power of 11 Now, I don't want to get into that too much here because it gets into the heavy math and we will get totally
Yeah.
lost and people's heads will spin, including mine. But the thing is that the thing that this is really good for is probability. This is the matrix to understand the probability for anything.
Now that sounds fascinating. I want to hear more about that.
Yeah, let's talk a little bit more about that. So
Yeah.
if I have 3 coins and I want to know the probability of if I flip these 3 coins, what's the probability that I am going to get all 3 coins heads? Look at this row and it'll tell you. It's 1 out of 3. The probability of getting 2 heads and 1 tail is right here. You got 2 out of 3 probability of that. And then you have the probability of getting all tails over here. And the probability of getting 2 tails and 1 head is right here. This gives you 4 for the same thing. Now, if I was in a Pythagorean school or in a Sufi school that understood this, I would take the tetractys and I would do this with it. I would continue out with this. And I will show you. This is how I would number it from 0 to 7. So this is the octave. Here's the probability for 5 things, for 4 things, for 3 things, for 2 things, for 1 thing. On and into infinitum. Now I come here. What do these numbers represent?
Powers of 2.
Yep. And how do I derive these?
Sums of the lines.
Sums of the lines. So if I have 4 coins that I'm going to flip, there are 16 possible outcomes that I can have. And here is the probability spread for what they are. So if I do 1 head and 3 tails, or if I do all heads, I have 1 out of 16 probability for that. If I do 2 heads, then I got a 4 out of 16. If I do the complete spread, and I'm pulling this from memory, so it may not be entirely exact. I can go back and check my figures, but you see how this gives you a sense of the probabilities of what we are looking at with any number of things. There's
So
a
the
whole bunch more in this.
Yeah, so the probabilities of particular outcomes within an
particular
array
outcomes.
of
And
outcomes.
what is the Enneagram all about?
The probability of outcomes.
Yeah, the Enneagram tells us the probability of outcome.
Mhm.
Now I want you to also notice that the natural numbers are all along here, 1, 2, 3, 4, 5, 6, 7, on
Yep.
into infinitum. But If I go over one more row, 1, 3, 6, 10, 15, 21, what could those be? If I have any of those numbers of, say, spheres, I can align those spheres or those circles into a triangle. Here, 1, 4, 10, 20, 35 on into infinitum, I take those spheres and I can organize them into a perfect tetrahedron. I can stack them together like that. So there are more things in this number sequence than we can talk about today. But I want to go back and have you look at this. You see the you see the hexagram here, or the hexagon.
So I just want to touch on Jonathan Teller's comment. He says,
Yes.
I can see a practical relation. Good.
Yes.
Yes, this is what I see. As a builder, I look at that diagram and I see a building, a triangular shaped building, with the bottom row being the foundation. And the numbers represent the weight that the foundation is supporting above it.
That's really brilliant.
So the threes are taking the predominance of the weight because they've got all that on top. But anything with a 1 is not supporting any weight. So it's only got a value of 1. I don't know if that is actually a relationship, but that's just what I see when
I would say that that would have to be a relationship. I don't have the math to see it myself right now, but I will probably sit down with my calculator and figure it out afterwards. But intuitively, I'd say that you are right.
Yeah, thanks, Jonathan. Thanks for giving us an example of how you might be witnessing this in day-to-day life. Thanks.
Yeah. You can also use this to calculate very quickly, for those of you who know your math, binomial coefficients. You can spread this pattern out as far as you need to and find all the binomial coefficients in the universe, which are useful for a lot of things. So think about the moving lines in here. 1, 4, 2, 8, 5, 7, 1. And let me go back. You can imagine the numbers here. 1, 2, 2, 1, or 1, 1, 1, 2, 1, 1, 3, 3, 1. Those would be the numbers there. And going with Jonathan's metaphor, because it's actually pretty brilliant, when you look at these 2 points on the Enneagram, these are the points that bear the most weight.
Yeah, so what does that mean to you in this context, Mushtaq? I'm sorry.
That means these are the heaviest places to deal with, in the sense of this is where the work really takes place.
All right, fascinating. That's cool. All right, cool. Okay, so who was about to chime in? I want to make sure they get the opportunity.
Let me get rid of these so we can just talk about it and I can see everybody. Ask me questions. We have gone for an hour now and haven't even begun to scratch the surface of this.
Chris and John. All right. Yeah, John, why don't you sorry, Chris. Okay. John, go first, then we'll have you chime in. Chris, go for it.
I was just curious about the significance of the hidden zeros. You can imagine them all on the outside, if there's any significance from a philosophical standpoint.
There is, but this is one of the things I can't say that Pythagoras talked about, but we know that as it came from India, we understand that the zeros represent an actual number. 0 is a number. It's not just a placeholder. And it's a very important number. We can't do modern math without an actual number 0. 0 is the point between negative and positive numbers, and the point between the negative positive line and the imaginary line. We're stuck with the imaginary line because some dude, it was Descartes actually, who was upset about how you can't do some calculations without this other number line. So he called them imaginary and he tried to scoff at them, but we use them all the time in math now. So the zeros represent that void point. And you can't really, if you're doing the addition, you can't get the ones along the lines without realizing that you're adding 1 to 0.
Yeah. So always on the edge of the triangle, then there are
So
zeros.
there'll
Okay.
always be a 1 on the edge of the triangle because the 1 above it is being added to a 0 above it.
Okay. And we're talking about the left and the right
Yeah.
sides of it. Yes. Yep. Okay. Awesome. Chris, you wanted to chime in.
I was curious to get your take on the nature of number and then numbers 1 through whatever you might want to talk about.
Yeah, see, it's Pythagoras would say numbers 1 through 9. But in the real world, it's numbers 0 through 9. And that's one of the things he didn't want people to know about. Each of these numbers has a meaning, has multiple meanings. And you can go to from the basic Greek philosophy, 1 is unity, it's the monad. 2 is the dyad, it's the it can represent power and limit and unlimited, which is kind of interesting, but limits are very, very important. 3 is harmony, and 4 is cosmos, and 4 is where things start getting spooky, because 4 is where you first start finding the irrational. And the 4 rows in the Tetractys add up to 10, which is the unity of a higher order. The Tetractys symbolizes the 4 classical Greek elements of fire, air, water, and earth, but also hidden within it is the 5th element of void or space. And I cannot stress enough how much the Greeks hated that idea. And I mentioned that the Tetractys represents the dimensions, up to 3 dimensions. And as you go down that triangle, you find more and more dimensions, and it gets weirder and weirder.
Is the diagram itself constructed top to bottom? So does it start with the top point?
Yep,
And
starts
then
with the top point,
flows
with the
down
first
from there?
triangle. Remember how I unfolded the triangles? It always starts with
That's right.
1 and unfolds out to the 3.
It just seems different than how I imagined a kind of geometrical, philosophical take on things. It seems like the center point would be more important, but in this case, it's starting from that top point, and then the center point becomes, I guess it could vary depending how far you
Well,
down you take that diagram.
the center point is actually just showing connection. Remember, these are, let me pull up the image again. And go back to the beginning. So you start with the simplest possible 2-dimensional figure, right? That you cannot make a 2-dimensional figure more simple than a triangle. Fewest lines needed to construct it. That Pythagoras would consider the basis of universal construction. And Buckminster Fuller would agree with him. He saw that the universe was threefold and sixfold in the way that it was put together. So, unfolding it into two, right? Then unfolding that into three. Unfold it down here, unfold this one down here, unfold this one down here, unfold this one down here, and you get the three. That's how he derived it. And then at these places, at these points of where the triangles meet and where there's an empty space, he put the dots. That's how you need to visualize this. Start with the triangles and realize it's a matter of unfolding. And this is very much like Gurdjieff's ray of creation. You remember the ray of creation?
You might want to expand on that if you're
Okay,
up for it.
that he talks about how the universe came down from the infinite to now, and he saw it as happening in a particular way, going from one splits into two, and because two cannot exist alone, it becomes three. 3 doubles to 6, 6 doubles to 12, 12 doubles to 24, 24 doubles to 48, 48 doubles to 96. And those were his levels of creation, where 96 he called the level of the moon, and 1 he called the level of the sun absolute. And each of these was a level of existence and a level of rules that limited being. So at the level of 3, you only had 3 laws that, or 3 rules that limited you. At the level of 96, you got 96 levels of constriction on being. That was his model of the universe. And I'm pretty sure that he pulled that in part, at least from Pythagoras, or people who were influenced by him. Now, how this ended up in Sufism, we have some conjectures. Remember I mentioned that Omar Khayyam was the guy who really mapped this out in Persia. Zainab, are you still with us? Yes, there you are. Did you learn about Khayyam's triangle in school? No? Too bad. It would have been somewhere around algebra. So, Sufis used this. They taught it to each other. It was part of how you learn to understand how the universe works, so you won't be surprised all the time when stuff happens. And how you can do things like calculate the weight of a foundation of a building and where most of the stresses are going to be, or the weight of the foundation of a civilization and see where most of the stresses are going to be for that. So that, I'm pretty sure, is how it ended up, because you may or may not know that while the West, what we call the West, lost all of the Greek corpus, they had none of the philosophers, none of the mathematicians, none of the scientists. They were preserved in Islamic culture. And Europe did not get them back in any real form until 1492, when Ferdinand and Isabella finished the conquest of the Iberian Peninsula and looted all of the libraries and got all of the Jews that they were holding captive to translate the text for them. And lo and behold, there's the entire preserved knowledge of Plato and Aristotle and all of these Greek philosophers and scientists and mathematicians right there in Arabic that they translate into Latin, sometimes badly. So Baghdad and Egypt and Iran were like the three main centers of knowledge for this kind of stuff back in the day. Interestingly enough, a lot of it was sent eastward, and I know that some of it ended up in Malaysia and Brunei and Indonesia as well. But that's also a story we don't need to get into right now, though I personally find it fascinating how knowledge gets disseminated. I should also say that this number pattern was also known to the Chinese from the 12th or 13th century on, and they have their own name for it that has nothing to do with poor old Blaise Pascal, the Johnny come lately who got his name hung on this pattern.
Too often that happens, huh?
Yep.
Yep. But it just goes to show how knowledge that we're uncovering now is like, oh, so new and, like I said, exotic and all that. Like, it's been around a very long time, and it's shown up in different places at different times throughout history. And in each case, it's been a very treasured piece of knowledge. So there we go. Do we have any last thoughts, Mushtaq, or anyone here this evening?
I just want to make sure that I have not just been talking past everybody, because this is, you know, like I said, this should be done over 12 weeks probably.
Yeah.
With mathematical examples of everything and exercises so that you can actually see how the whole thing works.
Yeah, I guess we could consider this a taste.
Yeah,
right?
this is nothing more than that. This is intro to, or even survey of.
Yeah.
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 How would the levels beyond the 4 dots relate to the Enneagram? Because the diagram you showed had up to the 1, 2, 3, 4.
Yeah, it went into an octave, and it relates to the Enneagram in orders of magnitude, but there's no time to go into that now, unfortunately.
Okay. Explain it all in the next 5 minutes.
That's definitely a question worth holding on to, though.
Yeah.
And I'm going to write it down so that we can stew over it and see what comes up to share with you all.
Yeah, to give you a hint on that, remember the end of every process on the Enneagram is the beginning of another.
Mm-hmm. Yeah. So yeah, I mean, one thing for you guys that might be fun would be to draw this out and experience it for yourself on paper. And maybe that will make it easier to follow if you had a hard time during this video tonight. Because sometimes when you're, being front loaded with verbal information, it's not quite the same as participating in it yourself. So definitely encouraging that.
Yeah, but this is the serious mystery school stuff.
Mm-hmm.
This is the kind of stuff that they taught in the semicircle to the inner circle of the school after they were sworn to complete secrecy and would never divulge it. This is the kind of stuff that if you were initiated into the right Sufi order, you will learn some of this stuff. And this is the kind of stuff, if you go to the right places in India, some of the old teachers there still know it. And I don't know if it's still known in China or not. All I know is that at one time it was.
Yep.
And I know that the triangle is still used.
The triangle.
Yeah, the way the numbers are laid out.
Yeah.
Because you can use it for so many interesting mathematical functions.
Yep. Yep. So the dot triangle, you mean?
Yeah. The number triangle.
Mm-hmm. Yes.
Yeah. I mean, if you've ever had to try and calculate binomial coefficients in your head or working it out on paper, it's a pain in the ass. But you can lay this out and use it as a table and just go, oh, there.
Yeah, I want to check that out. It's been a while.
This is when you need a binomial coefficient.
I'm a little rusty, but maybe this would help, right?
Yep. But for me, where it really shines is in probability space. This triangle is the probability space if you see it correctly.
Yeah, and we didn't get to touch on that too much, but again,
That's because it's secret. I can't
Yeah.
tell you all of that stuff, but I can tell you how to figure it out for yourself. I mean,
Mhm.
you can go now to any decent probability textbook and find the basics of this. This is no longer secret, mysterious, metaphysical stuff. This is
Yeah.
just science now, which is kind of cool.
Yeah, I'm seeing Peilon nod pretty enthusiastically. Seems like she's feeling the ping of recognition. Cool.
Yeah, at least you don't have to worry about getting thrown off the boat anymore.
Yeah.
Thank
well,
God.
Not today anyway. Maybe tomorrow.
There's always something to get thrown off the boat for.
But I will tell you, for instance, I do a little stock market investing. Not huge amounts, and I'm very conservative about it, but I use this tool to figure out the probability of a stock going up or down or staying flat.
Hmm.
Cherie, are you with us?
She is. I think we also have Jonathan. Did you have a
Yeah.
comment?
I'm here.
Yes, I did. I can see how this can be useful with predicting things that are scientific in nature, construction and movement of planes or even rockets, and or materials. I mean, growth of crops, of how food can be supplied, all things like that that have a practical, physical nature. But when it comes to human psychology, which I think interests us most, doesn't it get more of a stretch, or certainly more difficult to use something like this?
The problem is that human psychology is mostly mechanical. And as long as it's mechanical, it's predictable. So when you're dealing with, as Mr. Gurdjieff would call it, human in quotes, you can use this. It can be somewhat disconcerting because it's like you go onto Facebook, and if you understand how this kind of stuff works, you read a post and you know how that person is going to think about virtually everything. Because they work on a mechanical stimulus response situation. You take one person and you say, immigrants for South America. And I will know that this guy, this woman, and this kid over here are going to be horrified by this and be very, very against it. And these three people over there are going to be for it. And then a couple of people over here are going to be completely indifferent. The problem with this kind of knowledge is once you learn it, people become so predictable that it's tedious sometimes dealing with them. That's why I like you guys. You're at least not as predictable as the norm. Don't let it go to your heads, but you're all right.
Yeah. Does that answer your question a little bit, Jonathan?
Yes, very much. Machines are predictable
Yes.
as long as
Yes.
they're not broken machines.
Oh, even broken machines are predictable.
Okay.
Broken machines are the most predictable because sometimes they'll just sit there and do nothing no matter what you do.
True that.
Like a broken clock, you can tell us the right time twice a day.
Yep. John had to go. Too bad.
Yeah.
Bye, John.
And Travis had to go.
Travis.
John's still here, and we're good. Thank you, Jonathan. So, Cherie, we invited you to chime in about the
because
stock market.
Cherie knows everything that there is to know about the stock market, though she doesn't want to admit it.
No. I used a lot of Fibonacci numbers when I was predicting prices and feeling the tension of numbers. That's what I did a lot of.
That's amazing.
Interpreting.
Yeah, and the Fibonacci progression is
not really
found
that
in the
amazing.
triangle, by the way.
What's that, Mushtak?
I said the Fibonacci progression is found in the triangle.
So there you go. You didn't even realize it, Cherie.
61.8, yeah, 0.618, everything. It was just like, yep, just looking in that ratio, you're always noticing the tipping point. Once you go past that, it's going to go about this much. Don't try and look for perfection or anything like that. But this topic today is a really hairy subject. You know, it's just so many different intricate things, and it's just like, oh yeah, I haven't thought about that for a long time.
Yeah.
I have to admit. Oh, yeah.
Awesome, though. Thank you, Cherie.
Yeah.
Yeah,
It
but
does
at the
actually
time when you
sense of-
were working in the business, you had to have probability theory in your bones, just about. So.
Yeah, it was. It was the instinct of it was don't think about it too much. You had to feel it.
Exactly.
And I found that maybe because I naturally liked numbers at the time, that those who overthought it really got undone. You couldn't do that. So listening to now where you're trying to quantify it is quite challenging.
Another lifetime, huh, Cherie? Yeah.
Not going back there.
No, I didn't think so.
One should never
not
go
for you.
backwards anyway.
So do we have any other thoughts or questions? Palon, how are you doing?
I'm good. I mean, maybe I've just seen this triangle so many times before that it's one of those things where you've stared at it so much that you don't have any sense of wonder for it anymore, even though I probably don't understand half of it. But it's like looking at the binomial coefficients and thinking back to, this was something that's been taught to us pretty early on. It's almost like just looking at multiplication tables at this point. I'm just like, oh, yeah, I've seen this. My interpretation of it is actually kind of the opposite of Jonathan's, because for me it really is the addition, which means that each line lower is a process moving forward, and so it's like the next thing the because I do see it as the line on the bottom comes from the lines on top. So it's almost like the lines on top is time at t equals 0, and then you see the process moving forward, and the exponential growth is kind of what I'm seeing in the triangle pattern. But linking it to the Enneagram, that part is new for me. John's question about, okay, the Enneagram only covers kind of the first 4 lines. What about everything else? And so that's something that I am looking forward to.
Cool. Yeah, I mean, that just goes to show what we bring to this study kind of colors our experience of the content. And not only that, but there are things that are always going to be a bit beyond what we know and what we're familiar with. So I think we're seeing that with Jonathan. He's seeing structural things related to building, and Palon is seeing more mathematical, exponential type growth things, very much based in numbers and the abstract. And so it's fascinating to see those differences. And yet again, we have Cherie coming in where she's thinking about both numbers and the abstract and the probabilities of it all, and also the literal, prices of things and
the
predicting
psychology
those prices.
behind whether somebody is
That's true,
wanting to buy or sell. Yeah.
That too, yes. So many layers. Yep.
And Yeah, I was
Oh,
thinking
okay.
about this, and I was first introduced to the Pythagorean Enneagram around 1973, and I don't even think I've half figured it out yet.
Yeah.
I mean, I
I
learned
bet
something new
even
tonight because
did
I had
you?
never thought of it in terms of structure like Jonathan mentioned, and that's like that was an aha moment.
Yeah. So thanks for that. And this is stuff that I am to some extent learning along with you guys. You know, I don't have a lot of study experience of this aspect of the Enneagram myself, so I find it fun to learn as well. Chris, you're unmuted. Did you have something you wanted to chime in with?
Yes, I really just want to express my gratitude. Thank you so much for sharing these teachings with us. For me, this is close to my heart, and I'm very grateful. Thank you. Thank you.
You are
Thank you.
welcome.
Yeah,
Thanks for
absolutely our
inspiring us.
pleasure. Yeah. So now take this and run with it. Discover new things and then come back and tell us about it, because that's the only way we learn.
Yep. So, anything before we close? No? All right.
All right. Well, let me switch this over to
Oh, look at
gallery
that.
view.
Thank you, Chris. He's showing us a book page showing what we've been talking about tonight.
Yep.
Awesome. All right. So, yeah, Brady Bunch mode, right?
Yep. We're on Brady Bunch mode.
Wave goodbye, everyone.
Bye, everybody. See you
Take
next
care.
week.
Yep.